Welcome to Ask and Learn.
Okay, so for this reaction, you're given the following reaction coordinate diagram. I apologize, it's not drawn as nicely as is in the book. But from this, you want to answer a few questions. So the first one in part A asks you how many intermediates there are. So remember that intermediates are going to be at the bottom of the well. So you have A is going to be your reactants, D is your products, B would be intermediate 1, and C would be intermediate 2. So in this one, you would have two intermediates, which are I1 and I2, or rather B and C. For the number of transition states, you're looking at these structures here. So you have delta G1, delta G double dagger 2, and delta G 3 double dagger. So in this case, you have 3 transition states, which are delta G double dagger. In this reaction, your fastest step is going to have your lowest transition state energy. And so when you measure this, you want to look at the difference in energy between the reactant and the transition state, right? So if you go from here to here, and then here to here. So your fastest step is going to be your smallest free energy of activation, which is going to be step C to D. For part D, you want to look at whether A or D is going to be more stable. So if we say that we set some type of 0-point energy, now we can see that A is higher in energy than D. So if something is more stable, it has a lower energy. So D is going to be more stable. Let me just move this down a little bit. The next question wants to know the rate determining step and what is going to be the reactant of the rate determining step. And so your rate determining step is going to be your largest delta G. Now this isn't drawn as nicely as in the book, but if you look, delta G2, so your RDS is going to be this delta G double dagger 2, the structure here. So it asks for the reactant of the rate determining step, so that would be B. Okay. And then lastly, you want to look at overall energies. So your first step wants to know if you're going to be endergonic or exergonic. So remember that endergonic versus exergonic, you're talking about delta G. So if something's endergonic, delta G is going to be greater than 0. And if it's exergonic, delta G is going to be less than 0. So if you look at your first step where you're going from A to B, this overall change in energy is positive. So B has a higher energy than A. So B minus A is going to be greater than 0. So you're going to be endergonic. However, if you look at your overall reaction, so your first step is from A to B, your overall reaction is going from A, just move this down a little bit, your overall reaction is going from A to D. So because going from A to D, you go down in energy, so D is lower in energy, your overall delta G is going to be less than 0, so you're going to be exergonic.